Gentlemen, critical thinkers, independent researchers, let me start by thanking the organizers of this conference for making it possible for me to attend this meeting. The CE and PC conferences have been an eye-opener for me. My paper is a short one, only 3 pages. I start with the abstract. The law enunciated by Frenchman Charles Coulomb in 1784, giving the force of attraction or repulsion between 4 point charges in space, is the most important principle in physics. Nearly everything in physics hinges on Coulomb's law, I dare say. However, this law is not complete, as it does not express radiation from accelerated charged particles, and it does not include force of gravity between electric charges. This paper seeks to extend Coulomb's law by invoking aberration of electric field to incorporate a factor for radiation, and by adding a term to explain gravitation. We obtain a law applicable up to the speed of light with emission of radiation and mass of a moving particle remaining constant, contrary to the theory of special relativity. And on slide number 2, titled Aberration of Electric Field. We all have heard of aberration of light, discovered by the English astronomer James Bradley in 1725. This is one of the most significant discoveries in science, but now almost totally ignored. Hardly would you find aberration of light being taught in undergraduate physics courses. Aberration of light being regarded more of a subject in remote astronomy. And yet this is one of the most significant discoveries in science. Why is it ignored? Because it contradicts the theory of special relativity. The discovery of aberration of light is a direct indication of relativity of speed of light with respect to an observer. In fact, Bradley used this discovery to make the first estimate of the speed of light relative to the speed of revolution of the Earth around the Sun. An electric force is transmitted or propagated at the speed of light, and therefore a charged particle moving in an electric field will suffer radiation of electric field. Radiation of electric field is a phenomenon similar to aberration of light. If you look at this diagram, we have a particle at a point B moving with velocity v at an angle theta to the electric field from a charge q. Because of the motion, the electric field is deviated by an angle alpha, and it appears along NP. Alpha is the angle of aberration. such that sine alpha is equal to V over C sine theta. If you apply sine rule to this triangle NRP, you get sine alpha is equal to V over C sine theta. The accelerating force F on this charge K in the direction of unit vector U on a particle distance r from O is put as this equation. F is equal to KQ over 4 pi epsilon r squared CR squared into C minus V. Coulomb's law, as we know it, refers to force between two stationary charges. Here we are talking of force between two charges, where C minus V is the relative velocity between the charges. If V is 0, what you get is Coulomb's law, force of attraction or repulsion between two electric charges. You can expand F to give you this equation equal to m1 dv by dt, Newton's second law of motion, force equal to mass times acceleration. So really the operating equation is this one under the square root sign. If theta is equal to 0, what do we get? The force becomes Ke into 1 minus V over C. Please substitute theta is equal to 0 in this equation and satisfy yourself that you obtain, for theta is equal to 0, you obtain this equation. If theta is equal to pi, what do you get? You get this equation. In the case of if K is a negative charge, say an electron, then it is possible for it to move round the cube under the force of attraction. In which case, if it moves in a circle, in a circular path, theta becomes pi over 2, 90 degrees. If you have a particle moving around a nucleus in a circle, it moves at right angle to the electric field. So if theta is equal to pi over 2, what do you get? You get F is equal to minus E into the square root of 1 minus V over C. Please satisfy yourself that if you put theta is equal to 5 over 2 into this equation, you get this equation. If you put theta is equal to 5 over 2. Any problem? If you put theta is equal to 5 over 2, that you get this equation. Lorentz factor appears here, gamma, for a charged particle moving particular to an electric field, has nothing to do with mass. I'll repeat this again. The ubiquitous Lorentz factor has nothing to do with mass. It has nothing to do with length or time either. In fact, what I am saying right here is that there is nothing like mass expansion or length contraction or time dilation, as special relativity says. Please satisfy yourself that if you substitute theta is equal to 5 over 2 in this equation, you get this equation with the Lorentz vector gamma. I go to the third slide. Electric charge, field, and radiation. If you have an electric charge of magnitude Q in the form of a spherical shell of radius A, its energy is given by equation 1 here. This is a well-known classical formula for the energy of an electric charge Q in the form of a spherical shell of radius A. It's a well-known classical equation. Now, Coulomb's law of electrostatic force of repulsion or repulsion between two stationary particles of charge K and Q, distance r apart, is given by equation 2. This again is a well-known equation in physics. Coulomb's law for two charges stationary, where the electric field is defined in equation 2. Newton's law of gravity for force of attraction between charges Q and K. There is force of repulsion or attraction between two electric charges. There is also force of attraction between two electric charges. Equation 3 gives Newton's law of gravitation. If M1 is proportional to K squared, the mass of a charge is proportional to the square of the charge. And therefore we can express Newton's law as G M1 M2 over R squared, or a constant of proportionality, chi here, times K squared Q squared over R squared. You can see here that while the electrostatic force of attraction or repulsion changes with the sign of the charge, the force of gravity remains attractive, whether the charge is positive or negative, because the square of a negative number is positive. So if we combine, if you go to equation 4, we are combining Coulomb force with the gravitational force to get equation 4. The electrostatic force of attraction or repulsion and the gravitational force of attraction. We are making the force of repulsion here as positive, and therefore force of attraction becomes negative. In view of operation of electric field, the force F between two electric charges depends on the relative velocity between the charges, which gives us equation 5. All our effort here is to arrive at equation 5. Equation 5 is the extended Coulomb's law with emission of radiation and gravitation. This gravitation is there, although small. For ordinary terrestrial bodies, the gravitation is small. There's force of gravity between us, but it's negligible. And how much more between particles, but it is there. So equation 5 includes a factor for radiation and a factor for, and an addition for gravitation. If you have a neutral body is composed of an equal number of positive and negative charges. So for a neutral body, the electrostatic forces of repulsion and attraction cancel out, but the gravitational force remains and add up. Equation 5 gives a law with emission of radiation and with gravitation. Now for motion of an electric charge, of an electron where K is negative, what we get from equation 5 is equation 6. In which case the particle is moving perpendicular to the electric field, which will give you equation 6. A particle motion in a circle is necessarily constant. If a particle moves in a circle, it moves with constant speed and at the right angle to the electric field, which is moving around an electric charge as a nucleus. For neutral bodies, I said it again, the electrical forces cancel out everywhere, leaving the gravitational force. So we can say that the force on a moving charge particle is less than the force on a stationary particle. If you have an electric charge Q in an electric field E, the electrostatic force is EQ. But if it moves, the electrostatic force becomes less. Now the difference between the force on a stationary charge particle and the force on a moving charge particle gives you the radiation reaction force. If you check, you will find that in the theory of relativity there is nothing like radiation reaction force. There is in classical mechanics the Lorentz-Abraham formula, and there's also the Lamont formula in classical mechanics, but in relativistic electrodynamics there is nothing like radiation reaction force. But relativity adopted Lamont's formula for the radiation power. So I repeat this again. The radiation reaction force is the difference between the force on a moving charge particle and the force on a stationary particle. The radiation power is a scalar product of the radiation reaction force and the velocity. If you take the difference between the force on a stationary particle and the force on a moving particle, it will get the radiation reaction force given by equation 7. If you take the scalar product of the radiation reaction force, RF here, with velocity, it gives you the radiation power, RP, equation 8. For theta is equal to 0, the radiation power is given by RP equal to EeV squared over C. For theta is equal to pi, 180 degrees, you get the same expression for radiation power. But if theta is equal to pi by 2, the radiation power is 0. if you put theta is equal 0 in equation, theta is equal 5/2 in equation 8, you get the radiation power as 0. So if a charged particle moves perpendicular to an electric field, there's no radiation, like motion around the nucleus, as in the Rutherford's model of the hydrogen atom. Bruce will remember that we went through this last time. And now go to slide number 4. Conclusion. Making Coulomb law independent of velocity of a charged particle moving in an electric field led physics into the contraption of theory of special relativity to explain the speed of light being an ultimate limit. It led physics into the contrivance of theory of general relativity to explain gravity. And it led physics into the conception of quantum mechanics to explain emission of radiation from accelerated charged particles. What we are proposing here is that with equation 5, the whole problem of modern physics lies in having made Coulomb's law independent of speed of a particle in an electric field. Once we have Coulomb's law, you will find that eventually, excuse me, you will not need special relativity. Because if you look at equation 5, 1c is equal to v, the force becomes 0. Only the gravitational force may remain, and that is negligible. So if a particles move in an electric field, in the direction of an electric field, at the speed of light, the force on it is 0. So we have the ultimate speed of light without infinite mass. This certainly should be a great relief to physicists, because we have lived with this difficulty. What is an infinite mass? Any mathematical equation which gives you an infinite physical quantity, that equation is wrong. Nature is not so extravagant as to have an infinite mass. An infinite mass is the mass of the whole universe. How can you contain that mass inside a laboratory? The physicists have never measured anywhere, have never measured an increase of mass with speed. Conclusion number 2. Lorentz factor gamma has nothing to do with mass. Lorentz factor is the result of motion of a charged particle perpendicular to an electric field. It has nothing to do with mass, nothing to do with length or time either. Conclusion number 3. In the relativistic mass velocity formula, the relativistic mass in that formula is not a physical quantity. It is not a physical quantity. It is the ratio of electrostatic force to acceleration in circular motion. is a ratio of the electrostatic force in the charge times the field. And the acceleration is v squared over r. That was give you the relativistic mass. That ratio can become infinitely large without any problem. So what we have here with relativity is a misinterpretation of a mathematical formula, equating m with physical mass. It's not a physical mass, not a physical quantity. The relativistic mass, the relativists do all sorts of tricks to explain what this m is in the relativistic mass formula. I heard Debbie say they refer to the relativistic mass, and mass is mass. Somebody even argue that it is the momentum which becomes infinite, not the mass. Whatever the case may be, you cannot have an infinite mass. And the relativistic mass in the relativistic mass velocity formula is not a physical quantity. All physicists must feel relieved, because all my life, from a teacher of physics, a student of physics, teacher of physics, now retired, I have lived with this difficulty of an infinite mass. It was a relief to realize that really it's not a physical quantity. It's a misinterpretation of a mathematical equation. Number 4, a moving charged particle radiates energy only if there is a component of its velocity in the direction of an electric field. So a charged particle moving round in a circle around a nucleus does not radiate. But if it is dislodged, if it somehow received a knock and it is dislodged from the circular path, it radiates energy at the frequency of revolution before reverting back into the stable circular orbit. As a student of physics, what really enthralled me most was both stabilization with the Rutherford nuclear model of the hydrogen atom by using quantum mechanics. It was a brilliant hypothesis, but wrong. He used the wrong principles to solve a problem. Bohr's derivation was defective in that it did not relate the frequency of the emitter radiation with the frequency of revolution of the electron around the nucleus. I have a paper which did that, not using quantum mechanics at all. A moving charged particle radiates energy only if there is a component of its velocity in the direction of an electric field. Energy radiated is equal to the difference in changes of potential and kinetic energy. If you have a charged particle moving along an electric field, it radiates energy such that the potential energy gained or lost is different from the kinetic energy gained or lost, the difference being the energy radiated. In contrast to a neutral body moved in such a way that the kinetic energy lost is equal to the potential energy gained. Like the planets, they do not radiate energy, but move in such a way that the kinetic energy lost is equal to the potential energy gained. As we said earlier, for motion perpendicular to an electric field, there is no radiation. Rutherford's nuclear model of the hydrogen atom is inherently stable. There should have been no need for its stabilization by both quantum theory. The use of quantum theory to stabilize both nuclear model of the hydrogen atom was what gave the boost. In fact, it was the beginning of the quantum theory. I put it to you that quantum theory is absolutely unnecessary. But there can be no vacuum in knowledge. Wherever a problem appears, somebody somewhere will concoct a theory to explain it. And that theory may stand until it is proved to be wrong or it is modified. I think the most important outcome of this paper is that Rutherford's nuclear model of the hydrogen atom is inherently stable. There is no need for its stabilization by both quantum theory. Rutherford was very much worried when he proposed his nuclear model of the hydrogen atom, because at that time, that atom should not have survived. Classically, the electron will spiral around the nucleus and collide with the nucleus, but it didn't. Atoms are about the most stable entities in nature. Bohr came and stabilized it. And Rutherford regarded that stabilization as one of the greatest achievements of the human mind. And now go to the recommendation. I think we should not forget Bradley's discovery of aberration of light. Much as some powerful forces somewhere have tried to ignore it, if only the CNPS can revive it and promote it. CNPS to revive and promote James Bradley's discovery of aberration of light, while velocity of light c is a constant relative to the source. The velocity of light is a constant relative to the source of light. And velocity of light from a source moving with velocity b relative to a point of reference with respect to an observer moving with velocity v relative to the same force of reference is given by this equation. S is equal to c plus u into u minus v. Gentlemen, I really call on you to look at this equation seriously, given the speed of light with the velocity of light with respect to an observer. This should show that for a stationary source, relative velocity to the reference point, for motion of an observer in the direction of propagation of light, the relative speed is c minus v. If you move in the direction of propagation of light, your relative velocity is c minus v. If you move against the direction of propagation, your relative speed is c plus v. We have just been talking about redshift. Redshift is the result of relativity of speed of light. We're talking about the expanding universe. The redshift indicated that there is motion away from the Earth. If you move away from a source of light, or the source of light moves away from you, There's a redshift. And yet, we want to insist that C minus V is equal to C plus V, according to relativity. No matter which way you move, the speed of light remains the same. I really am at a loss that this has not been done away with. Must we mortgage our conscience, our intelligence, to go with relativity because of some powerful forces that insist on promoting it? Perhaps now, if we combine this with the relative speed when we move perpendicular to the speed to the if you move perpendicular to the direction of emission of ray of light, this is what you get. Number 3 here. Your relative speed becomes the square root of c squared minus v squared. Maybe if you combine 1, 2, and 3, you can really make the relativist think. If we do away with the relativistic cardinal principle of constancy of speed of light, because this is a cardinal principle of the theory of special relativity. If we do away with this, then special relativity comes tumbling down. If special relativity falls, general relativity also falls. Gentlemen, I am done. Thank you very much. I will be ready to answer questions now or later.
Go ahead. Somebody has a mic. Go ahead. Go ahead.
I'll make a comment. I think it's very important what you have identified as the limitations of electrodynamics. In the book on the universal force that I published, I showed that if you solve the 6 empirical equations of electrodynamics simultaneously to obtain the more general force law, it does take into account the emission and absorption of radiation and radiation reaction terms. And you don't employ any special relativity theory. It's really coming from Lenz's law when you combine it with these other laws. And so we didn't realize that, but Isaac Newton in his book, Mathematical Principles of Natural Philosophy, said that you need to, when you want to improve your theory, and you've got in your theory, or let's say electrodynamics, you've got a number of empirical laws, you need to combine them to find the more general theory. And so by doing that, you actually accomplish much of what you're presenting today. You don't have to go in and modify one of the laws, like Coulomb's law. It's actually built into the other laws. And so that's amazing that you have found it separately, but you can also obtain it by solving them simultaneously. And the copy of my book that you bought has that in there.
In fact, I like your book very much. I will read it from cover to cover. Thank you.
Hi. I have a question which has been bothering me for a long time. What is the evidence of an electron in a hydrogen atom? What is the evidence?
Well, the Rutherford arrived at his model after a series of experiments. And the hydrogen gas neutral, and therefore if we have a positive nucleus, there must be a balance of a negative charge somewhere. But what we have said is certainly a question. We have not, we cannot say 100% that this is what it is. It appears to be so.
You see, when 13.6 electron volts, the first ionization energy of a hydrogen atom is applied, a 511 kilo electron volt mass equivalent energy of electron comes out. So an ant, 13.6 electron volts, is doing a billiard ball hit on an elephant or an elephant of 511 kilo electron volts. And I had a problem with this when in school. And tomorrow at 2:15, when I give my presentation, whatever you have here will be put forth in a different way. The gamma factor times the mass of an electron produces 13.6 electron volts. And that is the radius which Bohr called the Bohr radius. So you'll get to look at that. And I'll have a different flip on whatever you said. The equations here you presented are correct, but there'll be a further deepening of understanding of the gamma factor, C, V, C square, and V square.
Thank you.
Thanks.
Any more questions? Okay, thank you very much.
Thank you.